Good morning, pre-calculus. Today we get to look at section 12-3, which the entire chapter 12 deals with a little bit of an introduction to what calculus is about. And calculus, just as a little preview, sets out to answer two questions that algebra before calculus could not answer. And one of those questions is called the tangent line problem. Now, what does that mean? Well, that means if we go back to the before calculus, which is basically any algebra before calculus, when you deal with linear equations or linear functions, again, it's very simple to find out the tangent line, or it's very simple to find the slope of those type of equations or functions, okay? And like linear equations, they're very simple. But now the question came up is how do you find the slope of a given point on any other type of function, be it polynomial, quadratic, cubic, exponential. Again, that is some of the questions that calculus set out to answer. So that is what this section's all about. This one takes a little bit more algebra work, and then when you get into calculus, you'll be able to understand from the derivation, you'll be able to see the shortcut, which Gottfried Leibniz and Isaac Newton figured out. Okay, so the question we want to ask is, how do you find the slope of a graph at any single point? So if we got a function, and if we were able to pick a point on that function, we're able to find the slope at that point using what the mathematicians of old figured out. Okay, it's what pre-calculus. When I say pre-calculus, I don't mean the class you're taking right now, but it's anything before the concept of calculus couldn't answer. All right, so it's very simple. Now again, all I'm going to focus on is this guy right here. This part right here, if you remember correctly, this goes back to section 12-2, which deals with specifically the limit process. Now again, the limit process helps us find what is called the slope of a point on a graph or a function. And this right now, they give it a fancy name of calling it a derivative. So, when you go to calculus and you see this little symbol up here, that tells us we're trying to find the derivative of a function. In this case, it's really trying to find the slope of that function at that point. So this is a relatively easy section. It's mostly algebra. This is the thing that you guys got to remember, and I'll do a couple of examples. So let's start off with our first example. Our first examples are, they're asking us to find the slope, or it's going to be synonymous with the derivative of some function. It's got to be a function, okay? Later on, we'll get into other types. I mean, calculus, they get into other types that are non-functions at some particular point. So if we have a point, let's say 2, 3, we can figure out what the slope is at that point 2, 3 of that specific function. And now the first one they're going to give us, again, is relatively easy. Okay, well, right here we know that this is a function. As a matter of fact, this is a linear function, and just by looking at this part right here, we know the y-intercept is 5, and we also know by looking at this, we know that the slope is -3. But now, with using the definition of a derivative, we could figure out really what the slope is of this function at any point. So again, in this case, this one is relatively easy. We already know that this is a line, and its slope, any point that you pick on that function, its slope would be -3. But what we got to do is we got to do using the limit process to do this. So again, what we got to do is to find the derivative of this function is we take the limit as h approaches 0 of this part up here. So all we do in this case is anywhere we see an x, we let it become x plus h, and then we subtract the function from us. So all this part down from here down is all algebra. then we get down to this part of the problem. We can't use direct substitution here, but we know that the h's cancel each other out. So the limit as h approaches 0 of this particular function will be -3. And this right here is the proof of the pudding, okay? Even though we know that that's a linear function. All right, now let's try another one. I've got 3 examples of one. Now if you look at this one right here, okay, this one right here is a quadratic function. It's going to make a nice little curve. I know that the y-intercept is -3. We know it has a vertical stretch of a factor of 2. It also is going up. Again, just by example, I'm not going to get into real detail. We're going to just make a rough sketch. That looks something like this. Okay? That is the graph of that function. Well, unlike the linear function, we don't know what the slope is anywhere along the graph of this function. So that's what Leibniz and Newton figured out using the limit process. There's other details behind that, but you'll see that when you guys take calculus. So the first thing we got to do is we take, once again, this is really important, okay? This whole box right here is helping you find the derivative of some function using this. It's called the limit process, or it's also called the difference quotient, okay? So again, all we got to do is take it. We got 2 times x plus h squared. So anywhere we see an x, we let it become x plus h minus our function. Now, I am on purpose putting parentheses around specific areas because that's where the biggest mistakes students are. Now, when you guys learn a little bit more of the limit of this derivative stuff, you'll be able to look at this, especially when you get into calculus, you'll be able to look at this and say, I already know what the derivative is, okay? That takes a little bit of practice, but you'll see it when you take calculus. All right, so the next thing we got to do is simplify this part of the problem. So x plus h squared becomes x squared plus 2xh plus h squared. And then I went ahead and did distributivity. Okay, so all we're doing right now is we're simplifying this into putting it in simplified form. All right, the next thing I did is, once again, did distributivity. Did nothing fancy here. All this stuff you've been doing since pre-calculus. The next thing we do is, if you look at this part here, we can do a little bit of cross canceling. Simplification. So we know 2x squared and negative 2x squared cancel each other out. And then negative 3 and positive 3 cancel each other out. And you're left with 4xh plus 2h squared all over h. Now again, I can't use direct substitution in here because if I let h equal 0, I'm going to get a 0 divided by 0. We can't do that. So what we need to do is take the numerator and factor out an h. And then when you cross cancel, you're left with 4x plus 2h. And now we can do direct substitution. So if we let h become 0, we get 4x. So now the derivative of this function is 4x. Now what that means is very simple. If I pick any point on this function, any point, it doesn't matter, okay? I can figure out what the slope is at that point. Very important stuff. So again, if we don't know what that is, I'll just make something up. Let x is 2, let x become 2. So if I let x become 2, at that point, if x is 2, y is going to be 5. Yep, 2, 4, yep, be 5. I may be a little off, but I'm spitballing here. Again, that right there tells me that that slope at that line will be a slope of 8. All right. Now, just remember, this part right here is where a lot of students mess up in. Take your time. That's all your algebra. All right, one more. Again, this one right here is also a quadratic. More importantly, it's probably just a polynomial function. Graph that and you'll see what it looks like. well, let's do that. Let me just graph that, just let you guys see this. Y equals 4x squared minus 5x. And if we hit graph, it's thinking. All right, there you go. There it is. There's the graph of that function. And we can find the slope of any point on that function using the definition of a derivative. So here we go, setting it up. Once again, it's going all the way back to this guy. We want to find f of x plus h. This x plus h gets put in place of any variable x of your function, subtracting your function from that. So again, here, anywhere we see an x, we let it become x plus h minus your function, and be very careful applying all your parentheses. All right, simplify. Okay, I did mine step by step. X plus h squared is x squared plus 2xh plus h squared. I did distributivity. I did distributivity here. Did another distributivity. And then from here, okay, we can go ahead and simplify, get rid of all our like terms. Okay, so we got 8xh, there's no way the h to get, we got a 5x and a negative 5x, they cancel each other out. There's nothing else that we can eliminate. So we're left with 8xh plus 4h squared minus 5h. Next thing we do is we factor out an h. And then when we factor out an h, they cross cancel each other. So we're left with the limit as h approaches 0 of 8x plus 5x minus 5. Anywhere we, I think I wrote something down wrong. I'll fix it. That should have been h. All right, let h become 0 by a direct substitution, and we're left with the derivative of 8x minus 5. And just like I did in the other one, if you pick any point on that graph, you can figure out the slope of at that point. So that is what section 12-3 is. A good portion of that is nothing more than algebra. And you got to remember this guy right here is the most important thing in section 12-3. It's going to be very important when you take calculus, and then when you start seeing a little bit of a pattern, we can derive derivative formulas. You'll see that in calculus. And that's about it, guys. All right. Thank you.